Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 17, 2025, about 2 days ago. This paper introduces Gen-ViRe, the first benchmark that treats video generators as potential world simulators, and shows a big gap between stunning visual quality and much weaker actual reasoning. The paper is titled, Can World Simulators Reason? Gen-ViRe, a generative visual reasoning benchmark. And as we dig into it, the implications for how we train and evaluate future models are quite significant. Also, the authors shared a GitHub repo for Gen-ViRe. Right now, it is more of a placeholder, with an initial commit and a README that has not fully loaded yet. So listeners can expect the implementation and benchmark resources to appear there as they finalize and publish the code. Figure 1 illustrates what it really means to treat a model as a world simulator for a simple maze task. The top instruction shows the goal. Move a red square smoothly along the white path without crossing black walls. The human row depicts mental simulation, where imagined frames track the square's motion. The MLLM row shows chain of thought reasoning, which produces symbolic coordinates instead of visual motion. The VGM row demonstrates chain of frames reasoning, where the model generates a sequence of maze frames that physically simulate the square moving to the goal. Figure 2 shows the overall layout of the Gen-ViRe benchmark as a colored wheel of cognitive skills. The inner ring names 6 core dimensions, such as perceptual, analogical, abstract, planning, spatial and temporal, and algorithmic and logical reasoning. Each outer wedge lists 4 concrete task types that probe that dimension, like maze navigation, Sudoku solving, or graphical analogies. VLA, or vision language action, means tasks where the model must coordinate seeing, interpreting, and acting in a coherent video sequence. Figure 3 gives concrete examples of what these Gen-ViRe tasks look like in practice across the 6 reasoning dimensions. Each panel pairs a short textual instruction with a chain of frame sequence that the video model is supposed to generate, so the entire row becomes a tiny visual story. The top panels highlight planning tasks like changing a light bulb or assembling Lego shelves. The middle strip shows algorithmic and abstract puzzles, covering Sudoku, geometry, 3-dimensional rule extrapolation, and Raven-style matrices. The bottom row focuses on spatial and temporal reasoning, such as navigating a cluttered kitchen or responding to a slowing car in highway traffic. Figure 4 explains how Gen-ViRe turns fuzzy notions of reasoning into a structured, auto-graded benchmark. The top row shows data curation, where the team defines the 6 skill dimensions, gathers tasks from web, datasets, and generators, then stress tests prompts through peer review. The middle panel illustrates how they craft precise criteria for each subtask, such as what counts as correct obstacle handling. The right panel then shows the vision language model autorator scoring each generated video clip against those criteria, so reasoning quality becomes a consistent numeric score. Table 1 summarizes how 7 video generation models perform across the 6 reasoning dimensions. The table shows that Sora 2 leads overall, with the highest average reasoning score and especially strong abstract and perceptual abilities, so it sits clearly in the top tier. Hylua 2.3 and Veo 3.1 follow closely, each with different strengths in planning and algorithmic logic. Seedance and Kling stay well behind, which signals that raw visual quality does not automatically bring strong reasoning. Figure 5 turns those table numbers into radar charts that reveal how each model's strengths spread across the 6 reasoning skills. A radar chart places each skill on a spoke of a circle, so larger, more even shapes indicate broader competence. The large orange shape for Sora 2 shows strong, balanced performance, while Hylua 2.3, Veo 3.1, and Wan 2.5 form smaller but still competitive profiles. The detailed mini charts on the right highlight how this ranking varies by specific subtasks like Sudoku, maze navigation, or visual matching. So stepping back, 2 takeaways stand out. Video generators already show sparks of genuine reasoning, but there is a sharp gap between pretty simulations and truly consistent, physics-aware problem solving. The benchmark makes that gap measurable, which means future progress can be targeted and accountable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.